Hey, hi, good evening, everyone. Good evening, friends. Right, welcome back to our session on SQL joins. So, before we understand the different types of joins and what is joins in SQL, we'll quickly recap what we have covered in the last day. Right, so in the last session, we have understood the concept of constraints, right, as well as the differences between union and union all operator. Am I right? So tell me the list of constraints that we have understood. What are the constraints that we have understood in the last session? Starting from primary key, then composite primary key, foreign key, unique, not null, check, default, as well as candidate key. So friends, in the last session, we have understood the concept of constraints and why are constraints a mandatory topic that one has to learn as part of SQL structured query language. Okay, so all these constraints we have understood, and practically we understood where these constraints are used. Constraints represent some kind of rules, conditions on the columns, on the fields. So the basic constraint is primary key. Primary key is a combination of both unique and not null. Okay, so a table can have only one primary key. Yes, we cannot have more primary keys defined in a table. Only one primary key is accepted. Then next to primary key, we understood composite primary key. Composite primary key is nothing but we are defining a primary key for more than one column. Okay, say for two or more than two columns, if you would like to go and define a primary key, that would become a composite primary key. That doesn't mean we have two or more than two primary keys. It means only one. The combination of all these fields, all these columns should be unique, and neither of the columns should have null values. Null values are not accepted as part of composite primary key columns. Then we also understood foreign key. Foreign key helps us to establish the relationships, okay, between the tables, and we can have n number of foreign keys, okay, that can be defined for the fields within a table. Then we understood unique constraint. Unique constraint restricts that particular column value should be unique. So each and every row value should be unique. No duplication is allowed. How many unique keys can we have within a table? Again, n. Yes. Not null. So no value within that column can have null value. Okay. So all the values of that particular column should have some value. Null values are not accepted. Then check constraint. Check constraint is like providing a condition on the column. Only if the condition met, okay, the values or the records will be inserted or updated. Constraints can we have within a column? We can define n number of check constraints. Here also it is n under not null. Default, when you don't pass any value for a column, okay, and if you have a default value to be inserted, we generally use default constraint for that respective field. So this will ensure null values will not be there, because the default value will be inserted every time if you don't pass any value. But if the end user passes any value, that new value will be inserted. Again, we can have n number of default constraints to our table, to the fields. And finally, candidate key. Candidate key ensures that uh, both unique and each and every column, I mean each and every row. Able to identify each and every row using any of the fields, those all are together candidate keys. And how many candidate keys to get you can have within a table? You can have n number of candidate keys, and one of chosen as primary key. One of the candidate key will be chosen as primary key. Right. So in simple, primary key is nothing but it's a candidate key. Anyways, so this is what we have understood, and we have also understood the differences between union versus union all. So what exactly does this union and union all perform? Union and union all are two operators within SQL structured query language. So these combine the tables vertically. Okay, you can combine the table in vertical fashion, one or the other. Okay, so union operator helps us to combine the tables in vertical fashion, which ensures that duplicates will not be present in the output operator. Whereas union, no, in the name itself, we have it is representing that all the records of all the tables will be as part of the output. So duplicates will not be treated. Duplicates will be treated. Okay. So in general, when you work on large data sets, you can observe this particular action. Okay, why it is slow compared to union all, because it has to ensure that duplicates are not present in the output, but union all will be fast. So in the last class, I have asked you guys data set so that you'll understand the difference fast. Right. So we understood the clauses, constraints, operators, data types, all the fundamental concepts are done. So today we are going to learn fundamental concept as part of SQL, as part of SQL, and it is join. So friends, what do you mean by join? Can you put some or can you throw some light on join? What do you mean by join? Use chart. Join is nothing but combining. No, it's nothing but combining. Okay, even now we are also going to perform the same action. So join represents combine. What you are going to combine? We are going to combine rows. Okay, so you see, I have a table. One, and in the same, I have one more table. This is table two. Okay, for suppose if your requirement is, then what would you like to do? Initially, join them. We would like to combine them. Yes, so you'll get some output. Nothing combination of both. On this output, I would like to work. So this is my requirement. But in order to achieve this output, you have to combine the tables. Okay, it can be two tables. Not to combine the tables, we have to perform a function called join. Okay, so we have to join the tables in order to combine them. But in order to join any two or more tables, there is a condition, friends. What is the condition? The condition is nothing but there should be a matching column. There one matching column in both the tables, or in how many tables that you are working on, whatever the count might be. All these tables, there should be at least one matching. If you have the matching column, using the matching column, I'll try to join the tables. That's what we do. Okay, so for example, if this is my matching column, I'll use these two columns, the matching column 1 and the matching column from table 2, to join the two tables. So we are going to do the same, the same task, but different types of joins. You have to understand the first your requirement, then you are supposed to use that specific type of join. Okay, so in this, what are the different types of joins, uh, example, and we'll work on it as well by understanding the types, right? So before that, I'm going to create, especially for understanding this joins topic. So I'll go back, workbench, excuse me. I'm creating a database and I'm naming it as, okay, it's done. I have created. So let me refresh. Do you see joins? Yes, I'm able to see joins database which got created. Okay, then I'm going to use it. Probably today we'll go and understand the concept of sets and relations. That we have learned as part of our schooling. Uh, you know, uh, the union concept, the intersection concept, everything we are going to recap today as part of this joins topic. Because if you are aware of the Venn diagrams, this joins topic will be very easy for us to understand, right? So once after creating the database, we are supposed to use it, right? So let us use it now. Is that database got selected? Yes. So that means we are using this database. Okay, then what is our first step? Before we apply join, we should have table. Yes, we should have table. Are there any tables? No. Let us create table. How many tables? At least two tables should be present. See, if I have one table, there is no use of performing join. So at least I should have two tables, right? So let us go and create two tables. Here are our two tables. So if you see, what are our two tables? One table is named as students. One table I'm naming it as students, and the other table I'm naming it as courses. Okay, so if you observe carefully, what is the matching column between these two tables? Tell me what is the matching column. I have created both the tables. One is students and the other one is courses. So in students table, I have student ID, name of the student, then course ID. Okay. I have also provided the data type. Then the primary key was given to student ID. Then with respect to table courses, yes. If you observe properly between these two tables, we have the matching column as course ID. Okay, so this example will generally connect with us because when we start real-time classes, okay, when we are soon going to launch physical classes. So as part of these sessions, we'll gather the data of the students. Yes, so that will be in one table, and in the other table we'll have the data for courses. But the matching column between these two will be obviously the courses. For better or for easy understanding, I'm mentioning with that ID. Okay, so student has registered for which course, we can get a clear understanding, right? So the matching column is course ID. Now the two tables have got created. We'll also insert the data because we should have the data, right? So let us also insert the data. First, I'm inserting the data into students table. Okay, so if you see how many students we have, there are 5 students, 1 2 3 4 5, and these numbers are representing course ID. The first column values are representing student ID, and next to it we have student names. Okay, so there are 5 students as part of our data. Okay, we have 5 students, and all the 5 students data we have in our students table. Don't, you know uh, when you are understanding any topic, it's better if you go and use very small data. You can grab the concept very fast. If you try to do it on thousands of records or millions of records, it will be a hectic task for you to understand. So don't never do it in uh, the opposite way. So that is the reason I'm just going with 5 records, because when I start doing the joins, probably many of you may not understand. So don't assume that we are working on small. For till we understand the concept, let us work on only small data. Okay, once if you are good at the conceptual part, you can start working on millions of records, right? So in the same way, I'll also insert some data into courses table. How many courses we have? Observe carefully how many courses we have in the courses table. We have 5 courses. One is Python, SQL, Power BI, AI, and machine learning. Okay, so in total we have 5 courses. So we also have the course IDs 101, 102, 103, 104, 105. Clear? But if you see in students table, 4 students have registered for different courses. Student 1 has registered for 101, nothing but Python. 2 has registered for 102, it's SQL. 3 registered for 103, that is Power BI. 4 has registered for AI. But fifth student, probably we just got an inquiry, but he or she did not, you know, enroll or did not register for any of the course. So that is the reason we kept it as null. Okay, so now what I'll do is, for better understanding, I'll also take, if possible, Excel, because that would be the easiest way to understand, because we can understand with respect to a TV. Yep. What is the name of the first table one? Table one is representing, you know, students. What are the columns do we have in student one? I mean, students. We have student ID. Okay. Then name of the student. Then what else? Course ID. Okay. So these are the 3 columns that we have in table one. Then next to table one, we have table two. where we have the course details, courses. Okay, what are the two course columns we have? One is course ID and the other one is course name. So friends, for better understanding, I'm also representing the data in this fashion so that it will be very fast. Uh, it will be very easy for us to understand. Okay, names randomly. Okay, so the course ID 101, 102, 103, 104, and this person have did not register in any of the course, so null. Then with respect to the data of table 2, it's 101, 105, and this is Python, SQL, Power BI, AI, ML. Clear? I just represented the data in table format, so that would be easy for us to understand, right? So we have two tables, one is students and the other one is courses. Clear? In both the tables we have the data as well. Okay, so 5 courses, 5 students, but the fifth student did not you know enroll or register in any of the course, so that is the reason we kept under the course ID it is null. Clear? So far, no questions. Now, let us understand. Okay, before that, again, for safe side, I will also go and check in, you know, MySQL workbench whether the data got loaded. I mean, whether the data got inserted or not. Yes, the data got inserted. Let us also go and check courses table. Yes, we have the data. The records got inserted in both the tables, right? Now, the first type of join is inner join. The first type of join is inner join. What exactly is inner join? Inner join represents the common records between the tables. I'll go back as I have promised, I'll go back to our schooling days. So assume this is set A and this is set B. Now, if this is set A and if this is set B, again, if you are getting confused, treat this as table 1, table 2. Okay, so now if I ask you what is the intersection or what is a common part between these two tables or between these two, sets, probably you will see this is the common part. Am I right? The shaded one is nothing but the common part, right? So inner join will return us only the common or the intersection part. Whatever the records which are common between these two tables will be given as the output by inner join. In simple, the intersection part, the common part. What if there is no match? Simple. If there is no match, the rows will not be included in the result set. And again, there is again a note, observe this. Sometimes you'll find only join. Join is representing inner join, friends. By default, if you see join, that means it is nothing but inner join. This is the default join type they use in SQL. So don't go to any other join because under joins we have multiple types. There are probably 7 to 8 different types of joins. So whenever you see this word join, it represents inner join. It is nothing else. Okay. So for better understanding, as I have told, we are going to use this example. We have the syntax for the inner join. The syntax for the inner join says select, then whatever the columns you want, you can have the columns with the table name specified before it. Table 1 dot column 1, table 1 dot column 2, table 2 dot column 1, table 2 dot column 2. Your wish. Depending on whatever you want to have in your output, you specify all the columns. Then from table 1, inner join table 2 on table 1 dot matching column is equals to table 2 dot matching column. So this is where we specify the matching column. This is mandatory. Okay, when you specify the matching column, it understands thoroughly that we are performing join, and moreover, what type of join will specify here. You are performing inner join, so this will be your left table, and this will be your right table. So table 1, table 2. So only the common part, the matching records from both the tables will be given as output. And whatever you specify as part of the columns, only those columns will be given, not all columns, friends. So keep it in mind. Okay, so I'll probably, explain you using this syntax. I mean, our example. Focus. What am I trying to get here? See what I'm trying to get. I'm trying to get students dot. So students is representing students table 1. Okay, students underscore id. So that means this column I want in the output. Then students dot name, that means this column as well. Students dot course id, this column as well. Table name dot column name, table name dot column name. Then what else? I also want courses dot course name. So table 2 dot column name. Then from table 1, inner join table 2. Okay, so students represents our table 1, courses represents table 2 on the matching column. What is a matching column? The matching column is course ID. Between these two tables, we have the course ID as the common column, matching column. So you have to specify clearly, friends. Table 1 dot matching column is equals to table 2 dot matching column. Okay, so if you understand this syntax properly for one join, for rest of all the joins it will be same. Only you will change the type. The type will be changed. In place of inner, you will come up with the next type. Okay, and it keeps on going. The syntax will be same. Okay, so understand the syntax. You need not by heart it also, but as part of joins, you'll be questioned on syntaxes in interviews. For sure, you can expect a question. Joins is very, crucial topic for beginners or even for intermediate guys. As part of SQL, you can expect a question as part of joins. Okay, so before I execute, tell me, what are the matching records do you have between these two? Actually, if I take, this is the matching column. Yes, this is the matching column. What are the matching records? So the matching records are nothing but 101, 101, 102, 102, 103, 103, 104, 104. These all are matching records. So we'll have all of them in our output. Will we also get null? Is null present in course ID? No. Is 105 present In this course ID, no, right? So you should get only the matching records. What are the values that are matching? Only those values you'll have it in the record output. But in the output, what columns you're expecting? Student ID, name, course ID from students table. Then from courses table, I want only the course names, nothing else apart from it. Okay, I can also mention courses dot course ID. Both of them are same, right? Anyhow, right? So not required. Still, you can, if you want to add, you can add it, friends. I'm executing. See, that is what we have discussed. Inner join. I hope it's making sense. Whatever the order that we have specified, did it change? No. First student ID, next name, course ID, course name. Order did not change. Whatever columns we have specified here, only those columns have been fetched. The data for these columns only has been fetched. No other column. I hope it's making sense. Good. So this is what inner join does. Inner join represents the common or the matching part, the intersection part. If the records, are matched, only those you'll have it in the output. Clear? Good. Now let us go to the next type of join. It is left join. What is left join? Left join means, left join returns us all the records from the left table, but only the matching records from the right table. So table 1, table 2. And if you ask me, you know, to shade the region for left join, the diagram will be like this. All the records from the left table. So this is my left table, right? I'm facing the projector. Even for you, it will be the left table. Okay, when you're looking at the screen, this will be a left table and this will be a right table. As we are performing left join, all the records from the left table, additionally, the common part will be given as output together. But can we have any record from the right table? No. Apart from matching, nothing else. Okay, so left join is also known as left outer. Both are same. Don't get confused. Some people call it as left outer. Okay, so even though if it is left join or left outer join, both are same. Making sense. Now, if you observe the syntax, any difference? Yes, the only difference that I see is instead of inner, it is left. Instead of inner, it is left. Whatever columns you want to specify the columns, then the syntax will be same, but replace inner with left. It will frame you the syntax for left join. Nothing else, friend. Okay, so at least if you remember the syntax for one type of join, you can frame the syntaxes for rest of all the types of joins. Making sense? Yes. So let's go and understand left join using our example. But this time, probably before I answer the question for the output, I'll give you enough amount of time. You are supposed to tell me what will be the output. See, select ID, name, course ID, course name. So the columns are same. From students table, the left table, left join, what kind of join it is? Left join. Then right table is courses on the matching column. So I'm performing left join on these two tables. So tell me what will be the output. I'll give you enough amount of time. Tell me what will be the output. Okay, let me keep it clear. I want the answer very clear. How many records will be in the output? Number of records. 5 rows are given. Course name is also null. Okay, accepted. So you mean to say we'll have 5 rows and 4 columns. How many rows will have in the output? Is it 5 or 4? 5. Good. How many columns? Obviously 4 columns. I have specified all the 4 columns. Okay. So for the 5th row, what will be the course name? For the 5th row, what will be the course name? For the student E, what will be the course name? Null. Good. Now I'll execute. Hope everyone is understanding, but anyhow I'll explain one more time. See friends, first of all, what are the common records? We know that these 4 are the common values between the 2 tables. So for sure you will have all these 4 records in the output, because we are aware of inner join output. Yes, but this is left join, so you should have all the records on the right table, sorry, left table. So that means for all the records from the left table should be present in the output. Do we have all the 5? Yes, all the 5 are given from the left table, but E did not register any of the course, right? So obviously the course ID is null. Do we have any course name for E? No. So that is the reason we have a null value coming from 5th person, 5th student, E. Okay, I hope it's making sense, friends. Okay, so the joins is easy topic, but when you do it on a data, depending on the size of the data, probably you get confused. So that is the reason initially practice on small data sets. Okay, step by step you have to increase the size of the data set. It's making sense, clear. Now next to left join we have right join. So can you guess what is right join? Yeah, Akhil, I'm not no that much foolish, I'm a bit clever. So probably left join I have understood. So right join might be the mirror image of left join. Am I right? Yes. Right join is a mirror image of left join. Opposite. See, left join means you are going. Left join will return all the records from the left table, including the matching. So right join will return all the records from the right table, including the matching. Okay. So all the records from the right table will be given as output, and the matching records from the left table. So same, and right join is also named as right outer join. Like how left join is named as left outer, right join is also known as right outer. The syntax is same. The same syntax. I'm not changing any of the syntax. Only the particular join type will be changed. Instead of left, you'll have right. So let us use it on our example. Let us apply it on our example. Come on, friends. So what will be the output? I'll show you the data. So for sure, how many records will be given as, how many records will have in the output? Will it be 2, 3, 4 or 5? How many rows will be part of output? 5 rows. Good. Again, the answer is 5. Why? The definition. What does the definition say? All the rows from the right table. How many rows we have in the right table? 5. So for sure you'll have 5 rows in the output, only the matching from the right table, left table, right? So you'll get all these 5 rows in the output, but wherever we have the matching for these rows in the left table will be given as output. But if you see for ML, do you have any matching there? No. There is no student who have registered for ML. There is no student ID registered for ML. So probably for these two values, you'll have null. You'll get null. Okay. So that is one thing you observe clearly. I'll go and execute right join as well. See. Clear? In the fifth row, for the name and ID, because no student have enrolled for machine learning, so obviously those particular two cells contain null values. How simple it is. If you understand the concept, you can apply it on, whatever might be the dimension of the data set, we'll not worry about it. But in the initial stage, many of us will get confusion. The main reason is this join is a small topic, okay, which will make a lot of us to keep in trouble. Okay, right. So done with inner join, left join, right join. Clear. Next to inner, left and right, we have full join. Full join, yes. Full join means, full join is also called as full outer join. So full join is nothing but the records from both the tables. All the records from the left table, all the records from the right table should be given as output. That is, will be given as output. So that is nothing but full join. Only intersection, inner join. Entire left table including matching point, matching records will be left join. Entire right table including matching will be right join. Both the tables, both the sets will be full join. Okay, so a full join is nothing but all the records from both the tables. Okay, but unfortunately, it's not unfortunate. MySQL does not support full join. Full outer join does not support. Not only MySQL, even if you are aware of, if you are aware of SQLite, okay, SQLite it does not support full join. Rest of the RDBMS systems like Postgres, MS SQL Server, Oracle DB, they support full join as well. But anyhow, in MySQL, if you want to get the output of full outer join, what we do is we use the concept of union. We use the concept of union. How does union help us is, we'll take left join output, then we also take right join output. So left join this part, am I right? So this is left join and this is right join output. So if you apply union all, this will be repeated. The common part will be repeated. So if I use union here between these two join outputs, then in the output of this particular query will not have any kind of duplicates. Only this will be repeated for once. So that is the logic behind it. Why not union all? Because if I apply union all, it does not remove the duplicates. But union, it works on the duplicates and the output will not have any kind of duplicates. No repetition. Right? So union, using union, left join and right join syntaxes, I'll go and get the output of full join. Here we have the syntax for full join in SQL. So generally, like how we are using it in case of right join, left join, inner join, in the same way, replace that type of join with full. But not in MySQL. MySQL does not support this syntax. If you are using MySQL as your database, okay, as your RDBMS system, then you are supposed to achieve it using union operator. Okay, that is the only possible way. So what is the syntax? So this will be left join syntax and this will be right join syntax. Between these two, go and use union operator. So the duplicates will be removed. So let us go and use it on our example. Focus, friends. Simple. If you observe carefully, this is left join syntax. Am I right? And this is right join syntax. This is not a big query. Okay. Whenever you see this kind of query, don't get panic. Okay. So this is a small left join syntax and this is right join syntax. I'm combining both using union operator. So this will ensure that in the output you'll have no duplicates. So tell me how many records we'll have in the output. I'm applying full join. I hope you got the concept of full join. So tell me in how many records will be part of the full join. How many records will be present in the full join output? Good. Keep it up. So my friend says 6 rows. So in how many rows you will have null values, my friend? Obviously 4 columns. Obviously it will be 4 columns because I have specified clearly 4: student ID, student name, course ID, and course name. Okay. So if we observe, we are going to get 6 rows. Good. But how many rows will have null values? 2 rows will have null values. What are those 2 rows? Can you specify? Obviously, one will be this row, student 5, whose name is E. This particular guy will have null value with respect to course ID and course name. And with respect to ML, even ML, no one has registered for ML, right? So obviously you will have null values for ML also, right? So let me execute. If you understand the concept, you can play. You can play with the syntaxes. See, how many rows? 5 plus 1, 6. 5 students, and the sixth one is machine learning. Okay, so if you observe, fifth student did not register in any of the course ID, so that is the reason we have null, and the course name is also null. For machine learning, no student have registered. We did not get any kind of admissions for machine learning, assume. Okay, no student ID, no student name, but no course ID also. Akhil, what rubbish you're talking? I have course ID. It's 105. How come I can get null value here? How can I get a null value? It should be 105, right? Friend, before you argue with me, scroll to the top, look at your syntax. What did you mention? From which table you are getting the course ID? I'm getting this course ID from students, Akhil. Okay. In students table, do you have course ID for ML anywhere? No. So that is the reason you see null. Instead of students, if you keep it as courses, if you are getting this course ID from courses table, then you'll get 105 here. So that is the difference. That is the difference. Why I did not get 105 in the course ID column for machine learning is the general question we'll have in minds. The reason is for ML, the ID is 105. Yes, that's true. But this information in which table do you have? I have it in courses. Okay. But which table are you are using for getting the course ID? I'm using students table ID. Then how can you expect 105 to be part of course ID? You change it to courses. If you change it to courses, then you can see this 105 in the output. Clear? Good. So we had a good understanding on the different types of joins. These are the primary types of joins that we use in real time. If you are working on any of the database, for sure you have to work. There is no other option. It might be a database or a cloud, because the data in the real world resides in these places only, either a database or a cloud. Okay. Again, if you work as a DBA, database administrator, you'll perform all such kind of activities. Not only a DBS, if you work in the fields of data, a full stack, a front end developer or back end, whoever it might be, SQL is a primary skill, and as part of SQL, for sure you'll use the topic of joins. Okay. In the joins also, we primarily go and use inner, left, right, full. Then the last type of join, that is cross join. What is this cross join? Cross join, it returns Cartesian product. What is this Cartesian product? For example, if you have two tables, right? So each row from table one, will be combined with each row of table two. That is representing Cartesian product. I cannot represent this over a sets and Venn diagram. So probably I can keep it like this. So this is table one, this is table two. So each row from table one will be combined with each row of table two. So this particular row will be combined with 1, 2, 3, 4, 5. Then second record from table one, same process until all the records of table one are combined with all the records of table two. That is nothing but cross join, and the syntax is very simple. So the question comes here: for cross join, you need not have any kind of matching column. Matching column is not required. So the syntax is very simple. Select the columns that you want, specify the columns, then from table 1 cross join table 2. That's it. Okay, from table 1 cross join table 2. This is the syntax. And we have our example. Let me go and do it. Yes. So what I'm going to get? I'm going to get student ID, student name, student course ID, and from courses table, I'll get courses name. From table 1 cross join table 2. That's it. So very small syntax. Let me execute. So how many records we'll have in the output? Can you comment? How many records we'll have in the output for cross join? 25. Good. How? 5 rows. 5 rows. I have 5 rows in table 1 and 5 rows in table 2. 5 multiplied by 5. 5 5s are 25. So I should have 25 rows in the output of cross join C. 25. Clear? Good. So that's all, friends, because these are the basic and the important types of joins. We had a good session today. We had a very interactive session, and it's been long time that we have interacted. We had very. I see many of you interacting with me. Good, keep it up. And in the future sessions as well, I'm expecting the same from you. Yes. So that's all for the day. And now I'll go back to our questions. So if you have any kind of questions, then we can discuss, with respect to the ongoing program. If not, even in the coming sessions and the coming programs as well. Thank you so much for the feedback. You are supposed to again put some kind of support from you. If you feel that website to download SQL. See, friend, again the same question. SQL is a language. Don't get confused. Okay, so SQL is a language. You are supposed to install any of the tool, any of the RDBMS system has to be installed. It might be MySQL, PostgreSQL, Oracle DB, or MS SQL, whatever it might be. Go to the official sites. You can download depending on the machine that you use. If you are using Mac or OS or Linux, whatever it might be, you're supposed to download upon the selected OS. Yes, so before you leave, one sincere advice from my side: do hands-on, okay, so that these concepts you can memorize for a long time, and as a kind of support that you're going to give, do share these wonderful sessions across your connections, as well as before you leave, I would like everyone to hit on the like button and also fill our feedback link. Thank you, my friend. So the feedback link has been provided. Share your valuable feedback as well as your suggestions, whatever it might be. And soon we are going to start new programs. I would like all of you to participate, and take back to the next level. Right. Any other questions? Yeah. See, it depends completely on the order that you specify. Okay, within the syntax, you're supposed to change the order, my friend. Okay, so it might be inner join or whatever might be the type of join. If you want to change the syntax, I mean the order, instead of table one, you go and use table two, then table one. Okay, you can change it. So the program we are going to start, we are going to do is machine learning is going to commence on the next Monday, and a free internship program batch one will be started on this Saturday. Okay. Yep. So data mining is nothing but part of machine learning. I would like to so use this opportunity and join those classes. Yes. Do hit on the like button, friends. Right. So that's all for the day. Again, we'll connect in the next session, and we'll take the SQL concepts to the next level. We'll grow day by day. Okay. So until then, do hands-on, do practice the topics that we covered so far. Right, we'll meet in the next session. Have a great day. Signing off. Bye.